Today, for chapter 6.8, we are talking about subtracting with renaming. And your learning goal today is to be able to rename to find the difference of two mixed numbers. Okay, but first let's talk about the problem of the day. So to practice for a race, Kara is running 2.5 miles. Okay, so her goal is to run 2.5 miles today. When she reaches the end of the street, she knows that she has already run 1 5/6 miles. How many miles does Kara have left to run? Okay, so after she's trying to run 2.5 miles altogether, and by the time she runs to the end of the street, she knows that's 1 5/6 miles. Is she done with her running for today? No, she still has more running to do. So the question is asking, how many more miles does Kara have left to run? Well, the important information is that altogether, she wants to run 2.5 miles. And by the time she runs to the end of the street, she's already run 1 5/6 miles. So we can figure out how much she has left to run by doing 2.5, the total amount, minus the part that she has already run. And that will tell us how much left she has to run. So just like yesterday, your first step is to use a common denominator to write equivalent fractions. Let's look at our two denominators, 2 and 6. Right off the bat, do we know what could be a common denominator? 6. Okay, so let's rewrite it. So 2 1/2 is the same as 2 and how many sixths? 3/6. Excellent. And 1 5/6 is the same as 1 and how many sixths? Okay, so we can rewrite this equation by saying 2 3/6 minus 1 5/6, right? Would you say that that is equivalent to our original equation? Okay, now normally we would start by subtracting the fraction part. Can we do 3/6 minus 5/6? No, because 3/6 is less than 5/6, so we cannot subtract without going into negatives, and we don't want to go into negatives. So step 2, and this is very important, write it down in your notebook, we will need to rename, and we don't have 2 and 6 plus. We have 2 3/6. We will need to rename 2 3/6 as a mixed number with a fraction. How can I rename 2 3/6 as a mixed number? Well, I can think that 2 is equal to 1 plus 1, right? And each one is how many 6?
6.
Yeah, is equal to 6 plus 6. So I can think to myself that 2 3/6 is the same as 6 plus 6, right? Plus what? 3/6. So how many 6s is that all together? If I have 6 and I add another 6 and I add 3, how many 6s is that all together? Adam?
That would be, I think, 15 6s.
15 6, yeah. And now I can rewrite my subtraction equation. Instead of 2 3/6 minus 1 5/6, I could do so your step 3 is to find the difference. So I could do 15 sixths minus 1 and what? What was it?
1 5/6.
1 5/6. Okay. Now I'm confused because look, I have a whole number part here, but no whole number part here. Am I going to be able to subtract?
No.
So could I do, instead of 6 plus 6 plus 3/6, could I keep this one as a whole number?
Yeah.
Okay, so I could rewrite this as 1 and how many sixths?
50.
Could do 1 9/6 minus 1 5/6.
Yeah.
And now can I subtract the fraction part and the whole number part?
Yeah.
If I have 9 6 and I take away 5 of them, how many 6 do I have left?
4.
And 1 minus 1 is? 0. Very important, I need to check to make sure my answer is reasonable and that it's in simplest form. Is it in simplest form right now?
No.
I can simplify it to be what? 2/3. And my label is 2/3 miles. Okay. Now, we know that these three fractions, these three numbers, 2 3/6, is equivalent to 15 6, which is equivalent to 1 9/6, because we can write whole numbers two different ways, right? We can write them as like this, 6 6. We can also write them as a whole number 1. So these three fractions are equivalent. Give me a thumbs up if you agree. And now we decided, for the purposes of our problem today, to use this one because we wanted to subtract 1 and 5/6, something that had a whole number part, that was 1, and then a fraction part, right? So this format suited our needs the best. Sometimes will this format suit our needs the best? Sometimes might this one suit our needs the best? Why is it okay to use whichever one is best? Rashika? It's okay to use whichever form suits your need the best because all three have the same value. They're all worth the same amount. It's like if I gave you 5 pennies and 1 nickel. Are they worth the same amount? But are there times when 5 pennies will work better than 1 nickel? Yeah, okay. We are doing 2 1/2 minus 1 5/6. Your first step is to write equivalent fractions using a common denominator. Currently, do we have common denominators? No. Do we know which common denominator we might be able to use? 6. Okay. Do we need to rewrite 1 5/6? No, right? A common denominator of 1/2 and 5/6 is 6. So what is equivalent to 2 1/2 using the denominator of 6? 2 and 3/6, just like before. This is just what we did, right? And then 1 5/6 can stay the same. Okay? Step 2 is to rename both numbers as a fraction greater than 1. And this is what Sarah was talking about, making both of those fractions improper fractions. So we can think to ourselves that 2 and 3/6 is the same as 6 plus 6 plus 3/6, otherwise known as how many 6? 15/6. Okay. Now 1 5/6 is 6 plus 5/6, otherwise known as how many 6 altogether? 11/6. Now we can subtract 15/6 minus 11/6. If I have 15/6 and I take away 11 of them, Jason, how many do I have left? 4/6. And then all you need to think to yourself is it in simplest form?
No.
To write it in simplest form, I need to put it as 2/3. Then I need to label my answer. I need to say that altogether, Kara still needs to run how many miles? 2/3 miles. Okay, excellent. Now in this case, you might find that writing improper fractions for both numbers is easier. But sometimes if you have like 103.5 minus 2 and 1/4, would it be easier to convert both into improper fractions? No. Okay, so you have to look at the scenario, look at the problem, and decide, is it easier to write 2 improper fractions or to write 2 mixed numbers? Okay.